Thank you. I should mention I started to work for Grafana half a year ago. Before that, I was at SoundCloud. I'm just mentioning that because it makes a bit of sense to understand some of the slides here. Also, I'm kind of this Prometheus person, and Prometheus had its childhood at SoundCloud. So that is all connected, more or less. Now it's no progress. No, it works. Okay, we have 3 acts in this talk. The first act is about the things this talk is not about, what I don't want to talk about, which is a bit weird, but I have to set the stage a bit here. SLO is a word that one does not simply put into an SLO. Is it? No. Hello? Does it work? Yeah. There's also SLI and SLA, and all these acronyms have a lot of meaning, and I could talk for an hour just about that. I kind of assume we have a consensus, whatever, working consensus on that, and I don't have to go into the detail. If you want to read up, there's a lot of literature. The blue SRE book that Google published like 3 years ago by now is one of my favorite tech books, and like I guess you like it too, do you? I hope so. Whatever. Like, you should read it, and it has a whole chapter, chapter 4, which is just about SLOs. And also you see, does that work? SLA, SLO, SLI, it's all there, even in the beginning of the chapter. So you can get on the same page if you read that. Also, I'm not doing subtleties about SLOs that can go wrong. SLO is like a favorite word of SREs. Of course, it's so great. Inform design decisions, to set the right goals, to set alerting in the right way. But it's everything that is good, totally overdue. This talk, which I saw at earlier this year, on and off, right? Perhaps I did something wrong here. Let's put it here. Perhaps that helps. Perhaps it works now. I might have squeezed the cable.
Oh, well, you can try this too. You have to hold it. Is that okay?
Okay, it would not be so. I'll try. If this fails, I'll switch to this one. No problem. We'll see how it works. Okay, thank you. SRECon earlier this year in Dublin, EMER, not America. They have a version for America as well. There were a bunch of super interesting talks. And, Narayan talked about how SLOs can actually go wrong. And this is I put this here as the enjoy SLOs responsibly slide. This is really nice to hear about what can go wrong. So if I talk about it, I don't want to raise the false impression that this is always just working. So you have to think, as always, you have to keep thinking. Another talk at SRECon EMER was latency SLOs done right. And I thought, oh great, this is probably exactly my talk. And I had already submitted the talk for KubeCon, and I thought perhaps I'm just telling the same thing again as Heinrich Hartmann back then. It's an awesome talk. Unfortunately, it's totally different from my talk. This is way more about the science behind measuring latency SLOs, which is extremely important. This talk is fairly hands-on how you could do it, and I think it's all mathematically correct, but in your situation, you probably have to do things slightly different. And once you do this, once you deviate from the recipe, you should actually know the science behind it, and then you should watch this talk. It's all video recorded. I have provided the links, so nice to watch. Okay. Then there's another hot topic, and this touches this whole metrics versus logs thing that is discussed more and more viciously in our community. I'm talking about alerting on SLO breaches, or let's say you get close to breaching your SLO and you want to get an alert in real time. That's metrics-based in the example I'm showing here, namely I'm using Prometheus. You could do the same thing with any other metrics-based monitoring system. The other thing is if you actually have a breach of an SLA, now I'm in subtle ways changing the letters here, like you have a customer, you have an agreement, and you have not fulfilled your SLA, then your customer gets some reimbursement, I guess, and that's now exact science. You want to give them the exact number of currency units as reimbursement, and then you don't go to your metric system, you go to your logs, and you actually do an exact calculation how much you have to return. So that's a different thing, because that doesn't have to be real time, it has to be exact. Your alerts, they should not be noisy, but they don't have to be like rocket science precise. Now, you could totally do the alerting based on your logs processing. If your logs processing is reliable enough and fast enough and everything, some vendors offer that these days. I think the principles I will tell you here, they still apply, because in the end, you're just creating metrics on the fly from your logs. So this whole talk is not supposed to tell you that you should use Prometheus for that. It's just kind of the easiest way to understand the ideas behind it, but it applies to all other metrics-based systems and arguably to logs processing as well. Okay, you can actually do logs processing, allows you to do like per customer alerting or something, even if you have millions of customers. Not sure if that's a good idea, but that belongs into this whole cardinality thing. But I don't want to get deeper. This is anyway all the stuff that I don't want to talk about. Okay, alerting. The other part in the title, SLO, was the first important thing. Now we get into alerting. How is alerting supposed to work? There's also interesting stuff in the Blue SRE book. Chapter 6, this is actually the evolution of this classical viral Google document that was titled My Alerting Philosophy. You might have heard about it by the same person who wrote the chapter. So that's where this whole cool aid happened with symptom-based alerting. And alerting on SLOs is actually a really nice example of symptom-based alerting. It's really good alerting. And to understand the whole philosophy behind it and also how to not overdo it, you can read that chapter. Also, the Blue SRE book has a chapter number 10, Practical Alerting from Time Series Data. That's also nicknamed the Beorn chapter because it explains how Google is traditionally doing metrics-based alerting and monitoring. Beorn is the system that was the spiritual grandfather of Prometheus, so that also helps you a lot to understand basic concepts, which I'm not talking about here. Okay, this is the most important prerequisite reading. I mentioned in the abstract. I hope you all did your homework and read it, if you haven't read it before. Alerting on SLOs. So this is not the SRE book. This is the Site Reliability Workbook, which is the what they call it, the sequel or something. It's kind of a second SRE book with more practical hands-on recipe-style instructions and stuff. So this is super hands-on, and it's really nicely done. This is one of my favorite chapters. It goes iteratively through different approaches of alerting on SLOs, and in that way you really understand it. There's the first obvious way of doing it, and then what is going wrong, and then you understand why you have this more refined way of doing it. The number 6 iteration is the one I want to go with here. So ideally you have read this all. If you have read it, perhaps you have read this as well. So this is where I mentioned I was at SoundCloud before. This is a blog post I wrote not too long ago, in summer. I think when this came out, I was already at Grafana, but anyway. It was a friendly transition, so I still wrote blog posts. So this is even more hands-on. This explains how we applied this chapter 5 of the SRE workbook at SoundCloud on alerting on SLOs. And it gives you all the context and details and everything. So it might also be a nice read. If you're lazy, I gave a talk version of that blog post at the Prometheus meetup in Berlin, which got recorded. I only discovered that just before I made those slides. So another link, this is now my own talk. So if you haven't read all of this, you can just be lazy and watch this talk. This is the prequel for the sequel, whatever. Part 1 of the movie, this is part 2 of the movie. If you haven't read this, I think you will still get something from this talk. Some parts might be a bit weird when we look at real PromQL expressions or stuff like that. But later you can read it up and then all the pieces will fall into place in your head, I'm sure. Also, I'm not going to talk about this. This is all the part I'm not going to talk about because this is all just about errors. This is only about error budget if requests end in an error and not yet latency. We'll come to that later. But to set the stage, even if you read everything, this is the super quick recap. This SLO-based alerting from chapter 5 of the workbook. The whole trick here is you alert over different time windows. So you have, in this table, you have different so-called long windows. You calculate average error rates over those windows, and then you alert on them. The easiest to understand is the one here. So you have a 3-day, fairly long window, and if your average error rate is exactly factor 1, the error rate you could sustain while not blowing your error budget. Let's say you want 99.9% availability, your error budget is 0.1% error over a billing period, usually a month. So if you have exactly this 0.1% error rate, factor 1, over 3 days on average, that means you're exactly burning your error budget as fast as you are allowed to, which is kind of not too bad, but if anything happens in the rest of the month, you are screwed, right? So this is why you would burn 10%, 3 days is 10% of a month. So you should do something about it. So you get a ticket because you don't have to wake somebody up. This is a long-term, slow error budget burn. During work hours, you can find out what's wrong in your system. So and then it goes up and up. It gets faster and faster. And the fastest one is the 1 hour window. And you have a pretty generous factor of 14.4. So that means with 0.1% error rate, if your error rate is 1.44 on average over 1 hour, you get a page. And you have burned, the moment you get the page, you have burned 2% of your monthly error budget, which is only happening in 1 hour. That's way too fast. This is why somebody has to wake up and fix it. So intuition tells you that 1 hour average is way too long for a page. If you have a serious outage, you want to know within a minute. But the intuition is wrong, and this is the second most important graph from the chapter. If you actually have like a 1.44% error rate, it's all logarithmic, that's about here, then it actually takes an hour to detect that. If you have a 100% outage, like in a 1 hour window, if everything is fine, 0% error, and then you have a very short amount of 100% errors, the average is 1.44% within minutes. So that's the interesting thing. Within less than a minute, this alert will page you, even if it's an average over 1 hour. So this alert has actually no problem with being too slow. If you have a full outage, it's pretty quick. Only if you hit this threshold here, 1.44%, it ceases to fire, but then this other 6 hour window takes over, and then the ticketing thing takes over. Read up the details if you don't get this now. This is just the recap. But the interesting thing is, you can look at pretty long averages and still get meaningful alerts on slow and fast error burn. And this is super non-noisy. It only alerts you if you actually are in danger of blowing your error budget. The problem with this alert is actually a different one. And I have to repeat this here as well, because this is the most important graph from the chapter 5. Where's my laser pointer here? So the blue curve is the actual error rate as it happens. So at t plus 10 minutes, you have an outage. Whatever, a few instances of your microservice go bad, and you have 15% error rate. 15% error rate. And what happens, the red line is this 1 hour average. So it takes 5 minutes for this red line to go above the 1.44% error threshold. So after 5 minutes, even with this partial outage, you get a page. Presumably, the engineer on call wakes up, fixes the problem within 5 minutes, good engineer, error rate goes down to 0, engineer goes back to bed, right? This is how it works. The problem is this red line will now stay above the threshold for an hour, because for an hour you have this error peak in your 1 hour average. And the alert is firing all the time. So what do? If you have this, you snooze it on PagerDuty, or you silence the alert on Prometheus, something like that. All good, you go back to bed. Actually not good, because if something happens here, like let's imagine the error spike is happening again for some reason, nobody will notice because you have silenced the alert. So what you want to go back to bed and be confident that you get woken up, if the outage returns, you want the alert to reset, this is how they call it, pretty quickly. And now this is the trick, and it's very simple but ingenious. You take the 5-minute average, and this is where we have the short window here, right? So for the long window of 1 hour, you take another window of 5 minutes, and you also calculate the average error rate. You couldn't alert on this alone. It would be way too noisy. Like a short error spike would page you. This is what you don't want. That's why you have error budgets. You are allowed to have a few error spikes. But if you alert on both curves being above the threshold, then you get the best of both worlds. Like this page is here because both green and red are above the fold. And once you have fixed the outage, the green curve will go down really quickly. So from this moment on, your alert ceases to fire. And that's pretty good, right? The red area there is when the alert is actually firing. That's exactly what we want. Okay, so this is the ingenious takeaway from this book. Okay, now how to configure all those alerts. This is a bit tedious. In the SRE workbook, they give you all the instructions how to do it in Prometheus. You can transfer this to other systems. It's really elegant in Prometheus, even if it looks a bit complicated. It's sometimes a bit manual work, and I recommend you use some kind of config management. At Grafana, we are JSONet fans, and I just had to put this here. I've also seen a few other talks that touch JSONet here. If you write a JSONet table here, this is almost precisely the same table, right? So you just type this table into JSONet, and then you have a bit of JSONet glue code that creates all the recording and alerting rules you need in Prometheus. Pretty good. That's not yet open source. I hope we open source this quickly. We usually open source all this config we have pretty soon. It's still kind of, because we played with it, it's not yet done, not yet pulled up into the open source part. It will happen soon. At SoundCloud, we did the same thing, but we hand-coded it. So this is the one of the alerting rules in its whole glory from the blog post. And this is the alert name. And then this is a recording rule you also have to write. You can look this up in the blog post. But you see here, I mean, it's very complicated. You don't have to parse this now if you haven't seen it before. But here you see, oops, sorry, I always hit this button. You see 14.4 is the factor from the table. Here we have the 1 hour, here we have the 5 minute, here's the logical and. You see all those parts. Here's the critical severity. It's all in there, right? You can kind of guess how that works. If you don't want to wait for Grafana to open source their SLO stuff, Matthias Leubel, who just had a talk a couple of hours ago, he is also a fan of JSONet. He created a SLO libsonnet. And so that it's not too complicated for people who don't like JSONet, he created a web frontend for it, which he put on his own website. So you have rule generation as a service. So this is how it looks like. You enter your availability target and the metric you want to apply this on, and then hit create, and you get all the Prometheus YAML files to feed to your Prometheus server. So very neat. Okay, but this is all what I don't want to talk about. Mostly pointers to others. Talk is half over already, so we should go to Act 2. This was all just about error, like requests that end in a well-defined error, like a 500 or something. But most of us, we actually care about latency, as our track host has told us already. So let's think about latency SLOs, right? Now you will see in the real world that very few companies give you latency SLAs. Then, right? Especially ISPs, they love to tell you something. Yeah, sure, we have 99.9% uptime. What does that mean? I kind of hate this formulation because it implies it's time-based. Especially my internet connection, I don't use it all the time. Like all the night, I'm asleep, I'm not using my internet connection, and even if there's a downtime, I won't notice, and my ISP will tell me we were up all the time, sure, right? So like not using it properly means free uptime for the service provider, which is kind of not nice for the customers. Then I have a 10-minute super important video conference, job interview, whatever, and my internet connection goes down. That's for me like a full outage. And they say, yeah, 10 minutes per month, that's 3 nines, it's fine, right? Yeah. So to be nice, you should always do this per request. That's also in Heinrich Hartmann's talk about latency SLOs done, right? So this makes way more sense. During each month, we'll serve 99% of requests successfully. Great, right? Per request, if I have a lot of requests in a certain important time and there's an outage, I can actually tell the service provider, that was bad, I want to get reimbursed. Okay, but there's no latency in there, which is kind of weird because if, like, let's say I have a request, I want to get a response from my service provider, my browser times out eventually, and I tell my service provider, okay, so timed out, this request didn't succeed, and my service provider tells me, no, it would have succeeded, it would just have taken like 5 minutes, and your browser timed out is your fault. But 5 minutes, whatever. Even if you do this internally, now we're like at an SLO level again, you often have this among microservices, independent teams, they should promise each other how well the microservice work. And then, like 1 minute response time or something, it could create problems because you might queue up requests and then your instances like run out of RAM or something. So you kind of want a latency in there, and it's implicit. Like everybody would agree that like if it's 5 minutes, it's like a failure. So what to do to put latency in there? And I went through this in many iterations, and like often people come up with something like, sure, we will have like 99.9% availability, serve 99% of requests successfully, and then like give you a long tail percentile latency, 99th percentile latency, that's pretty good, 500 milliseconds. Great, right? But thinking about it, like an error, the open 1% errors, they could actually be pretty fast. Like fail fast is a good design principle. So you kind of get a 503 in 10 milliseconds. That is counting against this error budget, but it's not counting against this one because it was served quickly, right? And then the 1% that are slow, they could be arbitrarily slow and still fulfill this SLO. And slow requests are kind of useless, so this would still allow 1.1% of requests to be useless without breaching this. It's not happening all the time, of course, but it's still kind of weird. And it's also like, now we can go to the service provider side. I want to alert on error budget, but I have two error budgets. I have open 1% errors, and I have 1% slow queries. Do I alert if I breach one error budget and not the other, or can I compensate one with, it's like all complicated. So what I actually want, and this is not always applicable, but I would always recommend to try, and I always ended up with this thought, slow requests are just as bad as errors, right? So just try to make them the same. Tell your customer, during each month, we will serve 99% of requests successfully within 500 milliseconds. So that means if an error comes in fast, it's still an error, obviously. If a request comes back but it's slow, it counts as an error. And it's fair. Like it's like customers can easily reason with that. I can easily reason with that. I have a clearly defined SLO. And I even think, I mean, this is pretty harsh. You could like lose some of the threshold, like 99.9% within a second. I think this is still better than something where you don't know if 1% of the queries will ever return in like finite time. So if you can do it that way, there is a problem if you have like a mixed query load. And this is especially true for us at Grafana. We have applied these ideas to our Cortex offering, which is hosted Prometheus. People ingest all the Prometheus data into our Cortex cluster, and then they can run PromQL queries against it. And of course, like every beginner can just type this super expensive query of death in Prometheus, and we can never serve it in like a second or something. But like law of large numbers or whatever it's called, like how often does that happen? Perhaps you can still commit to this thing. You can do more complicated things. And again, SRECon, my second favorite conference after this one. There was another talk about stuff at Booking.com where you had exactly this problem. And they actually created like buckets. They had buckets of expensive and not so expensive queries, had different SLAs for them. You can totally do that, but if you can avoid it, just avoid it. Which brings us to Act 3. I want to implement the easy solution for you to like see how that works. Of course, you can iterate from there and make it more complex. But if you can, just do the simple one. This is Cortex. We don't want to explain Cortex here. There are Cortex deep dive, intros, everything here at the conference. This is the interesting thing for those SLO-based alerts. You always want some kind of almost external entity which measures things. So you can see what the system is responding, how fast it is responding from the outside perspective, essentially. So at this SoundCloud blog post, we use our like edge load balancer for that. And in Cortex, you have something called Cortex Gateway. And then there is the ingestion path. I can't even see which color the ingestion is. It's the red one. So this is when people send us their Prometheus metrics and we have to ingest them. And then there's a write path where people, a read path, sorry, where like, for example, a Grafana dashboard queries Cortex to draw a dashboard. Or like some human interactively runs queries. Or some machine learning, whatever. Whoever wants Prometheus metrics from Cortex. So what do we do here in practice? We created a histogram, Prometheus histogram, on this gateway. And this had buckets, had many buckets, but we had one at 1 second and 2.5 seconds because these are our SLOs. We will see them in a second. And we partitioned this by status code, method, and root. Root is like read or write path. Now you might, if you're a Prometheus fan, you might have seen Prometheus people like me discouraging you from partitioning histograms because histograms are really expensive in Prometheus. And I more and more run into use cases where I want to partition a histogram. We just did it. Like we have big enough Prometheus servers to do this. Shameless plug, I gave a talk at PromCon very recently where I told people about my research of making histograms cheaper. So this will become better in the not too far future. But for now, you can just do it if it's not too bad because it's really useful. So our SLO we wanted to go with is complete 99.9% of writes successfully in less than 1 second and respond to 99.5% of reads in less than 2.5 seconds. So you might say, this is pretty lame, but it's also like PromQL. Like it could be really expensive, and also like a human hitting enter, waiting 2.5 seconds for a complicated query is probably acceptable. Most of them are faster, right? And even a dashboard, if you have to wait for 2.5 seconds, that's, yeah. I mean, most of requests should be faster, but that's kind of a reasonable threshold. To be clear, this is an SLO. We are not yet, we are still as lame as everybody else, are not yet committing to our customers to reimburse them if it's slower. But we want to, right? This is our intention. I think it's a good pathway to set an SLO, to inform your designs by this SLO. And then if you can make it and you can transform this into an SLA, it will give you a competitive advantage because your competitors won't dare to commit to that. Perhaps, who knows? So interestingly, there was a talk yesterday, I think, Blazing Fast PromQL. I don't know if you've seen it, by my boss, Tom Wilkie. He talked about a caching layer for Cortex, which works for Prometheus in general by now. And that was informed by this SLO. So you had this idea, okay, how can we even do this? Like people run expensive queries all the time, but then, okay, if it's just this one dashboard where this expensive query is run again and again, why not cache it? So we had an engineering decision or new like design of something inspired by our SLO. That's the way it's supposed to be, right? And now we have fast queries. Okay. So how to do this? Oh, sorry. So you create recording rules, and those recording rules kind of give you an error ratio where like slow requests count like errors. So this, you don't have to parse it all. You can look it up later. But you see this is the write rule, like write SLO errors per request. And there is, the orange parts are coming from the JSONet, like we have different intervals. This is just for 1 hour. So you have the 1 hour here. So that means we have a range of 1 hour. This is the histogram. We picked the bucket with 1 second because this is our write SLO, our target to do everything fast, 99% fast enough in 1 second. It's the push route because it's the write pass. We take from the histogram all the 500s and divide it by the total number. But this is very flexible. Like, you could change it to, for example, exclude 400s because the storm of 404s will be responded to really quickly, and that shouldn't be like free uptime or something. Whatever, like this is how we do it. You can mix and match here. And the read thing, again, over 1 hour, we take 2.5 seconds here, and we take the query path, which is the read path, again, status code 500 divided by all. Okay, I mean, you don't have to parse it now completely, but you can look it up later. Now we had this table in the original approach, which was just error-based. This table actually doesn't change at all. We use exactly the same principles. Once we have defined those recording rules, we are back to square one, essentially. We have now a recording rule that looks like error rate, but it's actually a rate of errors and slow queries. And from there on, it's exactly the same thing as what we had before. So this is an alert that almost looks precisely like the one from SoundCloud. So this is the write alert. Here's our other threshold. The 0.1 is the 99.9% inverted. Factor of 14.4 because that's the page over 1 hour. There's the 1 hour, right? And 5-minute window, again, same threshold. And you do this for every line in this table. JSON will generate this for you. You can also generate it manually if you want to type it. This is the read thing. So 0.5, 99.5% inverted, 14.4. There's the recording rule over 1 hour and 5 minutes and the end. It's all there. Okay. It's kind of quite easy once you have settled to this simple conclusion. And ideally you do that. If it gets more complicated, you can iterate on that. But like, I think at some point you will come back to that. Conclusions. So latency is actually very meaningful in an SLA, and we should give this service to our customers. SLO-based alerting is really a great idea, with caveats, of course, but yeah, it's still a great idea. Concluding from both of them, you should have latency in your SLO-based alerting because you want to have both of them, right? So, which could very well evolve into a real SLA. That's the other idea. You set SLOs a bit ambitious, you let it inform your design, and then at some point you can be really nice to your customers. Keep it as simple as possible. Like, don't start with like difficult to reason with definitions. Try to keep it really simple. And now, I mean, this is kind of lame, but it's true. As easy as possible, but not simpler. Thank you.
As before we leave, there is a rating app. You can just rate the talk. And any questions? We have some time to take questions.
Can you put all that stuff into the alerting inside of Grafana? What sort of tips would you use for that?
You mean the Grafana alerts?
Yeah.
Okay.
I wanted to make it easy enough that I could recommend this to customers that just use Grafana and don't want to have to write that.
Like, my personal relationship to Grafana alerts is difficult. I think this is great for like interactively doing this, but I think it's not really great for production-ready usage. What I want, like as a Prometheus person, I want to make alert creation way more interactive in that way. But I think these specific alerts are really, they are so like derived from first principles that I don't even think there's a good way of interactively like look at a dashboard and think this is a good alerting threshold, because this is actually informed by your SLA or SLO, right? So this should be better than just looking at a dashboard and think, okay, can we wing it? Like, how good is it? And it's all like very deductively created. It's kind of a counterexample to interactively creating alerting rules, which could make sense in other scenarios, of course.
Once you use the recording rules, though, to generate new metrics, maybe.
Sorry, that was?
Once you use the recording rules to generate new metrics, maybe that would help.
Use recording rules to
use recording rules.
The microphone is going off, and then I don't hear anything. Sorry.
Once you could use the recording rules inside to make new metrics, and then then you could use those to generate alerts on SLAs.
You mean to generate Grafana alerts?
Yeah. No.
Yeah, I would just like, I mean, there's research going on within Grafana on that. I would just be very hesitant to use Grafana alerts.
Okay, thanks. I just want to know if there's any tips that could help.
Questions?
Hey, thank you for your keynote. My question is regarding if you work in a distributed systems, we have a lot of downstream services, right? And maybe some of your systems are not, doesn't have, for example, any kind of distributed tracing, right? And what approach should you use on SoundCloud or Grafana to measure the latency on the edge? Because for example, maybe you are alerting something in the edge, but the problem is the latency on your backend system, you know? So in the end, you're going to have, for example, a lot of alerts in a chain of alerts because you have all your downstreams breach in the SLO.
Yeah, that's a very good question. I mean, these alerts are just to let you know that something is wrong. They are not there to let you understand what is wrong. I mean, you could use all your observability tools, which might include some like informational alert, as they call it, from your metric system. That might include looking at traces. There are various ways. That's like a completely different topic. But you also touched another one, whom to page, right? Like something is bad deep down in your system, but you get this, the symptom-based alerting just tells you very generally something is wrong. You don't exactly know what it is. At SoundCloud, we actually had, on the front-end level, we had the load balancer knew which backend would cause, like the load balancer had like 5 different backends, and it would page the team that is in charge of the backend that is currently causing the latency. Now that only saves the one level, right? You can go deeper and deeper. I mean, there was another interesting talk at SRE Con EMEA. It's very like advertisement for the conference, there was Luis, what's his last name? I only know him as Luis, like from Zalando. They wired in the tracing into their paging, into their alert routing. So they would check out via the tracing which service is actually bad right now and would page that team. Super interesting. I just for me, I always get a bit dizzy if I have a very complex system in my alerting chain. I want alerting to be rock solid and easy. And if it's really that bad and I page like 3 teams except of 1, it's perhaps acceptable. I mean, it's the bigger your organization, the worse it becomes, right? I heard that Amazon has this principle, we just page everybody in a very large organization, and I wouldn't like that either, but it's a hard problem. Do we have more time for questions? Otherwise, like I could put this in here if you want to ask Grafana people, especially Grafana alerts. There are people at Grafana who know them better than I do. There's a Grafana booth, and there's also a Prometheus project booth here in this project pavilion. And I'll be on either one at any given time. So you can always ask a question there. But if we have more time, no, we don't, right?
Thank you very much. Thank you.
Okay, thank you.